Hello friends, welcome back to our channel. So today we'll see a few more examples on directed acyclic graph constructions. And we have seen this is a one type of intermediate code generation. So there are four types of intermediate code generations. So postfix notation, tree address code, syntax tree, and directed acyclic graph. And this directed acyclic graph is an optimized version of syntax tree. So here also the leaf nodes will be the operands and internal nodes will be the operators, and mainly the construction of directed acyclic graph is used for removing the common subexpressions as well as removing the common computational expressions, and also this will be used for generating the optimized code. So all these things we have learned in our previous session, and the link will be available in the description. Just go through that. And now we in this session we'll see a few more examples on directed acyclic graph, right? So one thing we have to remember, before creating a node, so first we have to check whether that node is already available with the same value or not. If it is, we need not create the node, we can make use of the existing node. And if the node exists but with a different value, immediately we need to create a new node. Okay, so by applying all these things we will see a few more examples in today's session also, that if you are having still any doubts, so that will be clarified. So let us start this session. That's a DAG, and let us take a few examples. So let us take this example, a plus b into a plus b plus a plus b. So one thing we have to remember, that is an operator precedence. So among all these operators, the operator precedence is highest for parentheses. So first we need to evaluate, or first we need to draw the directed acyclic graph for the expression which is in between the parentheses. So a plus b, so empty. So we can create a node for a and b, and which is a plus. I'll write here a, b, plus. So this is a acyclic and directed graph. So a plus b, and here once again a plus b, once again a plus b. So the same values. Okay, same values. So the same will be a plus b, and again a plus b. First after, so we need not create once again the nodes for these two expressions. Okay, the same thing can be used for these two. Now what we have to do, among star and plus, this is having the highest precedence. So the star in between a plus b and a plus b, that means whatever the result we are having, so this is the result. So for this result only we need to apply the star. So what we can do, so you can apply the star here, and one arrow this side and one arrow this side. So same value will be multiplied. Okay, same value a plus b multiplied a plus b, and once again then plus again a plus b plus a plus b. So what is this, you can observe. So the complete result of this expression will be added with this one. Okay, so what is the expression? So a plus b into a plus b, that is one expression. The result will be added to a plus b. So here the result is here. Once again you can use plus, and that will be applied here. Sorry, the result should be applied with this one, right? This is the correct, this is the correct. Okay, so hope you understood. So first a plus b, which has been multiplied twice, so this one, which is again added with a plus b, so which is added with this result itself. So this is a directed acyclic graph. So here we are having a nodes. So the leaf nodes are the operands, and internal nodes are operators, and we are also giving some arrow marks. Okay, because it's a directed. Now we'll see one more example. So these are all the expressions given, and now we need to construct the directed acyclic graph for this one. So let us start with the first statement. So B and C. So there is no node. So we can create a node for B and node for C, and the operation is multiplication. So multiplication will be done here. So this is the DAG for first one. Next, this is completed, and this is, let us give a labeling. So A is this one. Okay, A is equal to B into C, right? Next, D is equal to B. Sorry, yeah, D is equal to B. So that means whatever the B value we are giving, that should be assigned to D. So B value. So B is already there. Okay, B is already there. So the data has not been modified. So this node itself, we can treat it as a D also. Okay, D and B both are equal. Now E is equal to D into C. E is equal to D into C. So this is a D, this is a C, D into C, which is nothing but E. So E is also same. Hope you understood. So A is equal to B into C. B already created, B node was created, C node was created, and we are performing the multiplication. Now D is equal to B. So B is already there. We can make use of that particular node. So I am giving a label for D. Next, E is equal to D into C. Already D is available, C is available. So which is of a same value. So I have assigned D with B, and the same thing, D into C, which gives E. I am giving a label as E. Now B is equal to E. B is equal to E. Now B has been updated. So B has been updated. So what happens? So this value becomes B itself. Hope you understood. See, B is equal to E. What is the E value? E value is this one, right? D into C, which is equal to B. So this value is B. Now B has been updated, not this one, this one. Next, F is equal to B plus C. F is equal to B plus C. So here we should not consider this one, because in the previous statement B has been updated to E. That means B is equal to D into C. So now the B value is this one, not this one. So B plus C. F is equal to B plus C. So we can give it as plus, and again this one, B plus C. Next, G is equal to F plus D. So this is a F. This is a F. Okay. So G is equal to F plus D. F is this one and D is this one. So D has not been changed. So you can simply write it as this one. So this is a directed acyclic graph for these statements. Hope you understood. So here what we have said, before creating a node, we need to check whether the node holds the old value. So here what happens? So D is equal to B and E is equal to D into C. B is equal to E. That means the updated value has been assigned to B. Now the B value has been changed here. So in the next statement, whenever we are trying to compute the B plus C, we need to use the updated one, not the outdated one. So we are giving a branch, or we are giving a node, the addition operation from this particular thing. Okay, because B is this one, not this one. So like that, we need to check whether the existing node holds this previous same value or not. If it has been updated, then immediately we need to create a new node, or we need to use the updated one. Okay, so this is one more example, and we'll see one more example and we'll wind up. Okay, so let us take this example. Here also we are having the parenthesis, addition operator, subtraction operator, multiplication operator. So among all these things, which one is having the highest precedence? Obviously parenthesis. So we need to create a node for parenthesis, all the parentheses. So first one, this one. So what is the A and B? So initially I'm creating a nodes for A and B and performing the addition operation here. So this is the addition operation. Then C minus D. So C is not available, D is not available, and minus is also not available. So simply I will write here C, D, minus, C and D minus. Okay. Yes. Then A plus B. Again A and B. The values will not be changed. So A and B. Again C minus D. Done. And then we are having some multiplications and additions. So the first preference will be on multiplication. So multiplication in between A plus B and C minus D. So what we have to do? So we need to apply multiplication here. Okay, multiplication here, and also this one, right? Yeah. Then what we have to do? We need to apply the addition operation. Okay, addition operation. So the same thing, addition in this way. So this is the addition operation. Okay, so hope you understood. So A, B, this one, and C, D, this one, and this is also a repetitive. Okay, once again repetitive, and again we need to apply the addition among these two things. Okay, the same thing will be added once again. So the same thing will be added once again. So the multiplication, see, this is a one multiplication and this is one other multiplication. The same thing will be added twice. The same thing will be added twice. So hope you understood. This is a reduced version of syntax tree. It's also a variant of syntax tree. Okay, so main use is we need not recompute the same things multiple times. Here we can see A plus B and C minus D were appeared two times. We are not computing them two times. We are computing only one time, and we are just giving the arrow marks. That means directions towards the operators which will be performed. Right. So I'll stop here and hope you understood about the directed acyclic graph, and just practice a few more so that you will be good at constructing this directed acyclic graph. Okay, so let's stop here, and if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.